Yo, 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 this is Mr. O. Yo, 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 Mr. O. And today we're going to learn how to graph absolute value inequalities. Absolute value, graphing absolute value is like a V shape. And if it's a V shape, it's an absolute value. If it's negative outside the absolute value, it opens downward. It reflects over the x-axis. Let's show it here. So again, the parent function of an absolute value is y is equal to absolute value of x. When we graph that one, it's just like a V shape. Okay. When we have y equals negative absolute value of x, this one opens downward. Okay. And now we're gonna connect it with inequalities. Inequalities are the one that anything involved with greater than or less than or greater than or less than or equal to. Okay, so we're gonna put them together and see what will happen to the graph. Okay, just some important thing that you need to know is that if it's greater than, you're gonna shade above portion of the graph of the V shape. If it's below, that means you have a y less than to the absolute value. And we all know that if you have a less than or greater than without equal sign, it will be a dash or dotted line. If there's a equal to for less than or greater than, it will be a solid line. So let's go ahead now. Graphing absolute value inequality. Here are the things that you have to remember. So create a table of values. Recall that the vertex should be in the middle row. And when we have a table of values, we just grab the expression on the absolute value and then set it equal to 0 and solve for the x. And then you plug it back to find the value of the f of x, and then complete the row by identifying the values on the left and on the right side of the x value that you got from the expression. Number two, use dash, and I mentioned this already. Use dash line or dotted line if it's less than or greater than symbols only. Solid line will have a equal to, like less than or equal to or greater than or equal to symbols. Shade the above portion of the graph if it's greater than or greater than or equal to, and below the line if it's less than or less than or equal to symbols. Okay, so let's do number one here. F of x is less than absolute value of x plus 1. First, grab the expression x plus 1, set it equal to 0. Minus 1, so therefore x equal to negative 1. So therefore, put negative 1 somewhere in the middle there. And then think of a number that are before negative 1 and after negative 1. So I'm going to put negative 2, negative 3, negative 4, and I'm going to put 0, 1, 2. Okay? Now I'm going to plug in this x values to the x right here. So if we have negative 4, absolute value of negative 4 plus 1 is going to be absolute value of negative 3, which will give me a positive 3 here. Negative 3 plus 1 is negative 2. Absolute value of negative 2 is positive 2. Negative 2 plus 1 is negative 1. Absolute value of negative 1 is positive 1. Negative 1, which will give us our vertex. Negative 1 plus 1 is 0. Absolute value of 0 is 0 there. 0 plus 1 is 1. 1 plus 1 is 2. Absolute value of 2 is 2. 2 plus 1 is 3. Absolute value of 3. If you notice, guys, here, this is our vertex. And look at the pattern. 1, 1, 2, 2, and 3, 3. The middle one is a vertex there. Okay. So after you get that one, you're gonna plot the points here. You're gonna go negative 1, 0 there, negative 2, 1, negative 3, 2, negative 4, 3, and then reflection on the other side there. If you notice, it will form a V shape. But hold on, before we connect the points, look at this one here. It's less than. According here, if it's less than, it will be a dash or a dotted line. So I'm going to connect them with a dotted line, arrowheads. And I'm going to highlight since that's less than, I'm going to highlight below the line. Below this one here will be this portion of the plane. There you go. So if I ask you a solution anywhere in the shaded area, okay, and this is dash, so any point along this V shape is not part of the solution. Okay. All right. There you go. Thank you. Move on. Boom. So f of x is greater than or equal to. So it's going to be a solid line. I know that already. And it's going to be above because it's greater than x minus 5 minus 2. Without doing a table of values, we can also anticipate where the vertex here. Okay, just a technique. The x minus 5, the negative 5 is inside the absolute value, which we'll learn in other video. So this is minus 5. It goes the opposite direction. And that means since there's a number inside the absolute value, there's a horizontal movement. A negative 5 tells you to go right 5. So you're going to go for right 5. 1, 2, 3, 4, 5. Right here. And you will go down by 2 because of the minus 2 right here. So 5 down 2 over here. That will be our vertex. Okay. All right. Then I will just make 1 up, 1 over, 1 up, 1 over. Those will be the points. It's going to be something like this. Okay. All right. But let's prove it getting a table of values, like what we did in the previous example. So we grab the expression here, this one here, the x minus 5 equal to 0. Solve for the x equal to 5. So put the 5 right in the middle of the table. And then pick a couple of numbers before 5 and after 5. I'm going to say 4 and 3. And I will have 6 and 7. Okay. Now, so therefore, I will plug in the 3 over C here. 3 minus 5 is absolute value of negative 2. Absolute value of negative 2 is 2. 2 minus 2 will be 0. 4 minus 5 is negative 1. Absolute value of negative 1 is 1. 1 minus 2 is negative 1. 5 minus 5 is 0. 0 minus 2 is negative 2. 6 minus 5 is 1. Absolute value of 1 is 1. 1 minus 2 is negative 1. 7 minus 5 it's 2. 2 minus 2 is 0. Again, this is our vertex. And if you notice again here, negative 1, and then 0, 0. So they're going to be the same, okay? And look, 5, negative 2 is the vertex that I anticipate right over here. And then we plot the points, 3, 0. Okay, here's the strategy in graphing it. 1 up, 1 over, 1 up, 1 over, 1 up, left, 1 up, left. If you notice, all those blue points are exactly the same coordinate to what I have on my table. Okay, that's a technique there. Up, it's a solid line, as we know, so we'll just connect them all. Arrowheads, arrowheads, and since above, because that's greater than, above the line is right here. Okay. Next, f of x is greater than absolute value 4x plus 6. Again, we're going to get the expression 4x plus 6, set it equal to 0, 4x equals negative 6, divide by 4x equal to negative 3 halves, or x equal to negative 1.5. I'll put it in the middle, negative 1.5, and I'm going to pick a couple of numbers before negative 1.5 and after 1.5. I would rather pick an integer to make it easier. So I'm going to pick there negative 1, 0, 1, and this is negative 2, negative 3, negative 4. If we pick negative 1.5 here, 4 times negative 1.5 plus 6, that will give you a negative 6 plus 6, that will give you a 0. So it's going to be, okay, let me just finish this one. Negative 1, 4 times negative 1 is negative 4. Negative 4 plus 6 is 2. As the value of 2 is 2 here. 4 times 0 is 0. 0 plus 6 is 6. As the value of 6 is just 6. 1, 4 times 1 is 4 plus 6 is 10. Absolute value of 10 is 10. So this is 10. Since we know this is our vertex, the strategy that I've been doing, I copy the 2, put the 2 here, put the 6 here, and put the 10 right here. To prove it to you guys, if I plug in negative 3 here, 4 times negative 3 plus 6, that will give me negative 12 plus 6. That's going to be negative 6, but they are inside absolute value. The answer is 6, and look what I have there, 6. So It just proves that it works. Okay. So anyway, so I'm gonna go to the vertex negative 1.50, which is right on the left over here, and then negative 1, 2, 0, 6, 2, 4, 6. I don't have space for the 110, so I can just leave it like that. And then reflection the other side there and right here. Since we have here a greater than, we will have a dash or a dotted line. Our heads. And greater than means above the line. So there you go. All right. Next is that we have f of x is less than f of x is less than the negative absolute value of 3x plus 9 close plus 4. Okay. So again, we will do the same thing. We're gonna grab the 3x plus 9, set it equal to 0, solve for the x there. 3x equals negative 9. X there is equal to negative 3. So that will be negative in the middle, right? Then we're going to plug in that negative 3 right here. 3 times negative 3 is negative 9. Plus 9 will be 0. Absolute value of 0 is 0. 0 times negative is 0. Plus 4 is 4 there. Okay. Um, we pick couple of numbers before the x, before the negative 3, I mean, before the vertex. So negative 2, negative 1, 0. And we're going to have negative 4, negative 5, and negative 6. We're going to plug in the negative 2 here. So that will be negative 2 times 3 is negative 6. Plus 9 will give you a 3. Absolute value of 3 is 3, but there's a negative there, so it becomes negative 3 plus 4 is 1. Next is that we plug in negative 1, so negative 3 times negative 1 is negative 3 plus 9 plus 4. This will be 6. Absolute value of 6 is 6, but there's a negative, so it becomes negative 6 plus 4 is negative 2. 0, 3 times 0 is 0, so absolute value of 9 is 9, but there's a negative, plus 4 will give you a negative 5. If you notice, there's also a pattern. 4 to 1, you subtract 3. 1 to negative 2, you subtract 3. Negative 2 to negative 5, you're subtracting 3. Okay? That should be a hint for you. And then you go reverse. If you go up, you subtract 3. What do you think will happen here? If you notice, this is 1, negative 2, and negative 5. We know that this will also be the same 1, negative 2, negative 5. Okay? Alrighty, so we plot the points here. So negative 3, up 4, up 4. And then 2, negative 1, 2, 1, negative 1, negative 2, and 0, negative 5. Boom. Reflection, reflection, reflection there. Connect them with a dash because this is less than our heads, our heads. And for this one, it's less than, we're going to shade the below portion of the graph, and that will be anywhere right here inside it. Okay. Alrighty. And that's how you graph absolute value inequalities. Again, remember, guys, if you have y greater than, you're going to shade above. Y is less than, you're going to shade below of the line of the graph. And if there's a solid line, it will be because there's an equal to the symbol of the inequality. We make a table, which a good accurate guide may not always be the fastest, but at least there's a table to follow as a structure way. We grab that expression inside the absolute value bar, set it equals 0, solve for the x, and then find the numbers before the x coordinate of the vertex and after that, and then you plug those into the function and solve it. And there's a pattern that any number above the vertex on the y value is the same thing on the below because they're reflecting, it's a v shape. All right, I hope you learned something. Kaboom.